Hey guys, hope you're having a good day. So, today for class, we are going to go through our student activity sheet 3 questions 8 through 10. So, with this, you should have already done the notes. If you have not done the notes, please go back and do those now for me before going through these reinforced questions, because in the notes, you'll find what a lot of this information actually means. Okay. So, looking at number 8, it says the graph of the parent function rule, f of x, which is our solid blue line. I've gone ahead and drawn over that line so that you can see it. Okay. It has been transformed to create the new function a of f of x minus h plus k, and that is our dashed line. Now, going back to this real quick, I don't like how Agile Minds uses a of f of x. So for this, all you guys have to know there, we could call it f of x equals a times k minus h plus the k. Okay. So don't worry about that F there. I think that's confusing, and this is the first time that all of us math teachers have actually seen it. Okay, so when we look at this, we have some fill in the blanks down here that we need to go through. So the first thing, it says the transformed function is blank than the original graph. So it's asking us if it is wider or narrower. So when I look at my blue graph here, and then I go down and look at my line down here, the dashed line, I see that it is wider than the original graph. So now they're asking us, what is it that could make it wider? And I know from the notes that it is our A term. It's this front term that determines if it is wider or narrower. Okay. So with that, there's some rules that we go through and follow. And I know that for a graph to become wider, it's that the A has to fall between 0 and 1. Okay, meaning it's if the second it becomes negative, all that does is determines if it flips the other way or not. But if it's bigger than 0 but smaller than 1, that means it's going to widen the graph up a little bit. If it's bigger than 1, that means the graph shrinks in size. It's narrower. Okay. So there I've used those two things. The next question is the transformed function is shifted to the blank. Well, so we're going to look. Where is it shifted to? I'm going to call it, and if you're wondering which one it actually refers to, it then refers to the H. So with the H, I know that I am talking about going left or right. Okay. So when I look at this, I see it is shifted to the left. Now, remember, with this one, what makes something turn to a negative or a positive here? So with this, it is shifted to the left so that I know that this term is actually going to be negative. Okay, now remember, if I plug that negative into the problem, it makes this turn to a positive using our double negatives. Okay, but before I plug it in, if I look, it's over here at -2. That means I know that it's a negative. Again, it may look positive in the actual equation. Okay, so that one's kind of tricky to navigate whether it's negative or positive. K. So now we're talking about K. K is what makes it go up versus down. Okay. So when I'm looking at this, I see it is shifted down. So I'm going to say it's shifted down. And when it goes down, that means that K is also negative. All right. So let's go on to number 9 here. Okay. So on number 9, the graph of the parent function rule, g of x is the solid line, and it has been transformed to make our new function. Again, guys, remember, I don't want that f there. You can just call it a of x minus h plus k. And that is now our dotted line. So using our choices here, we're going to go through. Okay, so the first thing they want to look at is the a term. Remember, that's talking about narrow or wider. So this time, if you look at our original line and compare our dotted line, our dashed line is more narrow. It's more closed in. So I'm going to write down narrow. And following those rules, I know that the bigger A is, the more narrow it's going to be. So A has to be greater than 1. The transform function is shifted to the blank, so H is what? So now I'm looking at H, and again, remember H, guys, tells us left or right. Okay, and this time it went left, and left is negative. Now looking down at K, it is shifted from here to here. It shifts down. And again, that's also negative. Okay, on to number 10. On number 10, it says, what values of A, H, and K will transform the graph of the original function f of x, shown with the solid line, so that it matches the graph of the new function y equals a of f of x minus h plus k. Again, going back to here, guys, we're going to call this a times x minus h plus k. So with this one, the first thing I want to look at here, okay, let's look at A. Remember, A determines the width of it. A determines the width of it, and it also determines the up or down, whether it opens up or down, okay? So in this case, I'm going to look what happens with my A. I go up 1 over 1, up 1 over 1. So here I'm going to go up 1, up 2 over 1. So it's actually narrower. So if it helps you guys, just make some notes. It's narrow. Okay. And then it also is negative. Okay, so those are the first things we have to look at here. Then let's look at what happens with our H. Okay, the graph is shifted to the left, which means that H is going to be negative. And now with this, my K, the graph moves up. So that means that's going to be positive. Now they want us to look at these values here. So we're going to actually fill in the blanks here. So we're going to say our new equation, you can call it f of x, you can call it the y equals. We're going to say blank times x minus blank plus blank. Okay, so A, on this A, when we're dealing with absolute value stuff, that's kind of like our slope. So here it went 1 to 1. Here it went negative 2 to 1. So we're going to call this a negative 2. And then I'm going to look at where it shifted over. It shifted over 1, 2, 3. So inside, we're going to call that negative 3. And then it shifted up 1, 2. So it's going to be plus 2. We have to simplify this out because this double negative here cannot be kept like that. So when we go ahead and simplify this, our final answer is going to be y equals negative 2 times x plus 3 plus 2. Okay, So now let's look at part B. We're going to do the same exact thing here. I want us to describe what is happening with A. There goes my light. What is happening with H, and what's going to happen with K. So from our original down to my dotted line, when I look at my H, I see it goes up 1 over 2. Well, here it goes down 1 over 4. Okay, when I'm looking for that point there, so this time it gets even wider. It's hard to see, but it gets wider, and it's negative. Okay, my H in this K, it doesn't shift left or right at all. So nothing changes with that. And it's at it's still at 0. And then my K with this, it shifts down. Okay, so let's go ahead and plug this in. We're going to say Y equals something times X minus something plus something. Okay, filling this in. Let's look at what the slope is here. Let's look at what the slope is here. Goes negative 1, 2, 3, 4. So I'm going to call it negative 1 over 4. My X, we said nothing happened there. And then where does it shift? It shifts negative 1. So simplifying this out, we would say Y equals negative 1 over 4 times X minus 1. Or we could call this Y equals negative 1 over 4 X minus 1. I don't like this particularly because it looks like this would just be a linear equation, and they're not having us plug in our absolute value bars that would make the triangle. But I just want you guys to see how that would simplify. If this was an actual absolute value equation, these would not be parentheses. They would be absolute value bars. And in the case of absolute value bars, we cannot remove them from the situation, from the equation. Okay, so go ahead and take a look at Canvas to see what your next assignment is.